In this video, we're going to go over all the quizzes that we need to know in order to succeed on or part 2 of our final. So first of all, the properties of exponents. This is kind of what everything is built on for this unit or these units. You must know the following. Before we even start, let's talk about what you must know. All right, so you must know that when you are multiplying variables with exponents, you have to add the exponents, and I am not going to get into why, but super important to know that you're going to add the exponents. Also need to know that if you're dividing variables with exponents, you have to subtract the exponents. And if you are raising a power to a power, so for example, something like this right here, we have to then multiply the exponents. And we spoke about why that is during the year. Hopefully you remember, but if not, well, you just have to know that that's what has to happen. All right, so some other rules, but those are the 3 major rules that you need to know. All right, so here we have x to the 7th times x to the 9th. We are multiplying, so therefore we have to add the exponents. 7 plus 9 is 16, so the answer is x to the 16th. Here, they're dividing, so we have to subtract. So we have k to the 12 minus 8, 12 minus 4 is 8. So the answer is k to the 8th. We're raising something to the power of a 0, and so that's actually one of the other rules that we need to know. Anything to the power of 0 is always, 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 always equal to 1. So that is something that you have got to know. All right, so this is actually 7 power to power. 7 times 0 is 0, which gives us 1, because anything to the power of 0 is always equal to 1. And here we have p to the 3 to the 10th, power to power. We have to multiply the exponents. We get p to the 30th. All right, but it gets a little bit harder. So whenever you see something like this, where you have numbers, you have x's, you have y's, different variables, I think it's a good idea to break them apart. So we can say 9 over 3. And then we can say x to the 5th over x squared. So I'm putting the x's together. And then I'm going to put the y's together. So y to the 7th over y to the 6th. All right, now it starts to look a little bit easier. Well, we all know that 9 over 3 is just 3. So don't get tempted to subtract these just because we're dealing with exponents over here. 9 over 3 are just regular numbers, and they work the same way they always have. But now these are variables with exponents, so we do have to subtract the exponents, and we get x to the 3rd and y to the 1st, but we can leave that invisible. And so that's our answer, 3x to the 3rd, y. All right. Now you may be wondering why this is not fully simplified, unless you remember that it's not okay to have these negative exponents. So whenever you see a negative exponent, and this is the last rule for this quiz that you have to know, moving it from the numerator down to the denominator will change the exponent from negative to positive. So here we have n to the 5th, it's positive, so it stays up top, but m to the 3rd is negative, so we have to bring it down, and we get m to the 3rd, p to the 1, and we can have that 1 invisible, so that's actually our final answer. We just brought these down so that our exponents could become positive. All right. Now when you see a bunch of stuff and it's being raised to a certain power, that means each and everything in the parentheses is being raised to that power. So really, 4 is being raised to the 4th power, and that is not a power to power. It's just a regular number being raised to the 4th power. So 4 times 4 times 4 times 4. And that should give you 256. So that's the first thing we raise to the 4th power. Everything else is just a variable with an exponent though. So we are going to have to do power to power, which is multiply our exponents in order to figure out what the answer is. So x to the 3rd to the 4th gives us x to the 12th. I just multiplied the exponents. Y to the 5th to the 4th gives us y, and I'm multiplying the exponents, so y to the 20th. And 7 to the negative 2 to the 4 gives us, that's not a 7, that's a z. All right, it gives us z to the negative 8. Now, we just learned that we should not have a negative exponent, but that's not a huge deal, easy to fix. We can just take that whole variable with its exponent, bring it down, and it will make the exponent positive. So the answer here is 256 x to the 12th that's a 12 right here, y to the 20th all over z to the 8th. All right, now we just learned that when you have a power, everything outside the parentheses, everything inside the parentheses is raised to that power. So 5 squared gives us 25. P to the third squared, and remember we're multiplying exponents here, gives us p to the 6th, and then q squared is just q squared. And we're also squaring the denominator, so we have p squared. But that's not fully simplified, and the reason for that is because we actually still have a p on the top, p on the bottom, p in the numerator and the denominator. So that means we're dividing, and we can go ahead and subtract those exponents, and we get 25 p to the 4th q squared, and that's our final answer here. All right, now moving on to the next quiz, where we are going to add and subtract or terms or polynomials. All right, so now a couple things to remember for this quiz, and I'll make a little side note over here. We can only add and subtract like terms. So we have to pay attention to what a like term is. The next thing is that we need to be careful of that negative sign, like here, when it's in front of parentheses. So a negative sign changes everything that comes after, well, when it's outside of that parentheses. So I'll just say, be careful. That's supposed to be careful over here, of negative, and that's between parentheses. All right. That said, let's go ahead and start. So I like to drop all my parentheses, and if I have a plus sign between the parentheses, I can go ahead and drop the parentheses without worrying about changing any signs at all. So, and that's only if I have a plus sign. So I'm going to rewrite this, and it becomes 2y squared plus 7y minus 5. Notice no signs changed before the plus sign, and no sign will change after the plus sign. I'm actually going to just say minus y squared minus 3y plus 4. All right, so we're going to go ahead and we're going to join our like terms. So I'm just going to use a little code here. If it has a y squared, I'm going to put check mark. So check mark here as well, and there's no more y squared. So we have 2y squared minus y squared, and that gives us y squared. All right, so I'm going to use a squiggly for everything with a y. So 7y minus 3y gives us plus 4y. And finally, I'm going to use a straight underline. So minus 5 plus 4 gives us minus 1. Since there are no more like terms, we know we're done, and that's our answer. All right, so this is going to get slightly harder, especially since there's a negative in between the parentheses here. So just remember, think of this as a -1, and you're distributing that -1 within the parentheses. So basically, every sign in the parentheses changes. So that becomes -x cubed or minus x cubed. That becomes plus 3x, and this becomes minus 5. Nothing, however, in the first set of parentheses will change. So we have 2x to the third plus 4x squared. Again, nothing changes in the first set of parentheses, minus x minus 7. And then in the second set of parentheses, because we have a minus there, it becomes minus x to the third plus, we're changing each and every one of these signs, plus 3x minus 5. All right, so now we can go ahead and join like terms. I'm going to put a check for everything with an x squared there, x squared there. So 2x squared minus everything with an x cubed. So 2x cubed minus x cubed gives us 1x cubed. And now squiggly, 4x squared. And lo and behold, there is no more 4x squared. So I feel like I wasted that squiggly, but that's okay. Plus 4x squared. And straight line underneath the x's, minus x. Plus 3x should give us plus 2x. And finally, I'll put the check mark above the number. Minus 7, there is no y there. Minus 5, there is no y there. Those are like terms. We have minus 12. And we go ahead and double check. There are no like terms here, which means this is fully simplified. All right. Again, it starts to look even harder because we have multiple things happening here with the A's and with the B's and with the numbers, but that is okay. So the key is to just keep work neat and organized. So here we have 4 a squared b squared, I laugh because already my work is not that neat, minus 3a squared b plus 2ab squared minus ab. Now this is a plus sign, which means nothing here will change when I drop the parentheses. It will all stay the same. So that's plus 2a squared b squared minus ab squared minus 3ab plus 9a squared b. No squared. Okay, cool. All right, so you want to just go ahead and quickly double check to make sure that you have not randomly dropped a square or added a square or changed the sign that you shouldn't change, and so on and so forth, and everything looks good. So now it's time to start joining our like terms. So I'm going to go ahead and put a check mark under anything with an a squared b squared. It has to have the same variables and exponents. Both variables with their exponents have to be the same to be considered like. So a squared b squared, the only other one is over here. So we have 4a squared b squared plus 2a squared b squared, which gives us 6a squared b squared. All right, so I'm going to go ahead and use a squiggly underneath 3a squared b. So then I'm looking for another a squared b. I can't find any until I get all the way over here. So we have minus 3a squared b plus 9a squared b. So that means we have plus 6a squared b. All right, now I'm going to use a straight underline under 2ab squared. So I'm looking for a b squared, and I found an a b squared right here, and that's the only one I found along with this one. So 2ab squared minus ab squared, which is really like 1ab squared, as you know. So 2ab squared minus 1ab squared is 1ab squared. So plus just regular ab squared. That one can be invisible. All right, and now we're ready for ab. So there's negative ab here, minus 3ab, and that's all there is for ab, that guy and that guy. So that is minus 4ab. And then we go ahead and double check to make sure that no terms are alike and none of the terms are alike, even though they look kind of alike, but they're not. So we're done with that one. All right, so we have another negative sign here. So we get to practice changing these signs once again. All right, remember that the first set of parentheses, nothing changes. So we have 2mn minus 4m squared n squared plus 4m. And now with a minus sign, every sign within this parenthesis will change. So we have minus 6n minus 2mn plus, because that changes from a minus, 5m squared n squared plus 3m squared n. And we go ahead and we start looking for like terms. All right, so as far as mn, we have that guy right here, and that guy right here, and 2mn minus 2mn actually is 0mn, so they cancel each other out, and so it's no need to write that. Feel like I wasted a check mark, but that's okay. All right, so I'm going to use a squiggly under the m squared n squared. So minus 4m squared n squared. I'm looking for another m squared n squared. And I found one right here, and that's the only other one. So minus 4m squared n squared plus 5m squared n squared gives you 1m squared n squared. So we can just write m squared n squared. And we try to be as neat as possible. All right. So I'm going to use straight underlines under the m's. There is a 4m here, and there is no other, just m So we have a 4m, and I will use a check mark above, 6n here, and no more. So minus 6n. And so all of these we've done, The only thing that's left is the 3m squared n. So we just rewrite that, plus 3m squared n. There's nothing like it. And so we go ahead, we double check that there is no like terms that we forgot to pair up or match up, and we are done. So that is how we add and subtract our polynomials. Now we're going to go ahead and start multiplying polynomials, which is a fun one, I think. All right, so if you have a polynomial, if you have two sets of, I guess you call these, well, doesn't matter what they're called. If you have two sets with two terms each, you can do what we say is called FOIL. First, outer, inner, last, which means we're multiplying the first thing here by the first thing in the other set of parentheses. So x times x, as you know from our earlier quiz, is x squared. And we just took care of the f in FOIL. Then we go ahead and multiply our outer terms. That's what the O in FOIL means. So x times 2, and we get plus 2x. And then our inner terms, 5 times x, we get plus 5x. And our last terms, 5 times 2, we get 10. But we know from our last quiz that we shouldn't just leave like terms hanging out without simplifying them. So we have an x here and an x here. So we can go ahead and join those like terms. Plus 2x plus 5x gives us plus 7x plus 10. All right, let's keep moving. We're going to FOIL once again. First, outer, inner, last. So first times first, 2p times p gives us 2p squared. Then outer, 2p times minus 5 gives us minus 10p. Inner, 2 times p gives us plus 2p. And the last, 2 times negative 5 gives us minus 10. Now we can go ahead and join our like terms, and we get 2p squared, because nothing's like that, minus 8p minus 10. Oh, that's supposed to be a 10. All right, so there's no more like terms, and that's how we know we're done. Now, we can only FOIL first, outer, inner, last if we have two terms in each parentheses, but here we have more than that. So what we want to do is make sure we're taking each of these terms and multiplying it by everything in the other parentheses. And the best way to go about doing this is being organized. It's not hard, it's really just about making sure you've done all the multiplications. So I'm going to start with x, and I'm going to take x and I'm going to multiply by each and every term in the other parentheses. So I'll do that first. So x times 2x squared gives us 2x to the third. X times 4x gives us plus 4x squared. And x times 1 gives us plus x. Now, it appears I did not give myself enough space to deal with the 3, but I'm going to do so anyway. So now I'm going to take the 3 and I'm going to multiply by each and everything. Whoa, boy. In my other parentheses. So here we have 3 times, I think that was a 2x squared. Yes, I believe it was. So 3 times 2x squared gives us plus 6x squared. 3 times 4x gives us 3 times 4x gives us plus 12x. I really hope I'm seeing this correctly. And 3 times 1 gives us plus 3. All right, I do think I saw it correctly. All right, now it's time to look at like terms. There's nothing like the 2x cubed. I'm not going to waste one of my marks, so I'm just going to rewrite that. All right, but now we have 4x squared here plus 6x squared there So it's plus 10x squared. Now a squiggly for the x's. Oh, there's only one, so I'm just going to rewrite it as plus x. And a squiggly for my 12 and my 3, those are like terms, plus 15. I did definitely drop an x here, so this is not correct. That was supposed to be 12x, right? 3 times 4x was 12x. So in fact, we did have a like term with x. We had plus x plus 12x, so this is wrong. Plus x plus 12x should be plus 13x. And then we have at the end that by itself, plus 3. All right, so now that should be right. So be very careful and check your work as I just did, because of course sometimes we do make mistakes. All right, so this last one is just like the one above, but it just uses our exponent rules a lot more. We have to really know those exponent rules. So this time I'm not going to make sure that I'm not going to waste the space. So we have 1, 2, 3. We're doing those 3 multiplications by the first term here. So 3m squared n squared times 2mn gives us 6m to the third n to the third. Taking this and now multiplying it by negative 4m squared, we get minus 12m to the fourth n squared. And taking that and multiplying it by our 7, we get plus 21m squared n squared. All right, looking good. That squared is way up there, but it should be down here, and that is okay. All right, so now we can go ahead and multiply this by this, and that, and that. We're taking that 5 and we're multiplying it by everything. 5m. Okay, so minus 5m times 2mn gives us minus 10m squared n. Now taking the negative 5m and multiplying it by a negative 4m squared, we get plus 20, handwriting deteriorating, plus 20m to the third. And finally, taking the 5m, the negative 5m, and multiplying by plus 7 gives us a minus 35m. All right, let's see if we have any like terms. Appears we don't have any more m to the third, n to the third. We don't have any more m to the fourth, n squared. We don't have any more m squared, n squared. We don't have any more of this, that, or that. So that's actually fully simplified. All right, so it's time to move on to the next quiz. All right, so now we get to practice our word problems. And this is actually the only type of question that word problems will show up on in our final exam for the part 2, for the second part. All right, so a gardener has a rectangular plot of land that is 3 meters longer than it is wide. And then he extends the length and some other things happens. But they want us to draw first the original plot of land. So I'm going to go ahead and draw that original plot of land. It is rectangular, so we should know what a rectangle looks like. This kind of resembles a rectangle, but it's not perfect. So we know that it is 3 meters longer than it is wide. So if we call this the width, W, then its length is 3 meters longer, so it's W plus 3. All right. Then this gardener, he's feeling pretty ambitious. He decides to extend the length of his plot and the width of his plot by 5 meters each. So drawing the larger plot, just pretend it's much larger here. Everything gets extended by 5 meters. So W gets extended by 5 meters, and W plus 3 also gets extended by 5 meters. I can actually go ahead and write this W plus 3 plus 5 as W plus 8. All right. With that information, now we're supposed to somehow Figure out the dimensions of the original plot of land. Sounds a little magical if you don't remember that they're actually saying that he extends that and this increases the area by 90 meters squared. That will help us to figure out the answer. So basically, they're saying if we take the area of this, which is length, base times height or length times width, so W times W plus 3. So if we take that area and we add on another 90 meters squared, we will get that area, which is base times height, so W plus 5 times W plus 8. So we take this area, add 90 meters squared, we get this area. So now it's time to set this up. So W times W plus 3 plus 90 should give us W plus 5 times W plus 8. All right, now we have to take what we learned and solve. So let's see how this is going to work. Well, we can now use our distributive property to figure out that this is W squared plus 3W. And then we have that isolated plus 90 over here, so plus 90 is equal to, and we have to FOIL this because we have two terms in each parenthesis. So first is W squared, outer is plus 8W, inner is plus 5W, and last is plus 40. Get that down in here. All right, so whenever you're solving an equation, if it's a quadratic, which we hadn't learned quadratics yet, quite yet, when we did this topic, but if this was a quadratic that you could solve by factoring and all that good stuff, you'd want to make everything equal to 0. In this case, we're just trying to get W by itself. Now, a good thing to notice is that we have W squared on this side and on this side. So if we went ahead and subtracted W squared from both sides, what would happen is a beautiful thing. You'd actually eliminate W squared from both sides. So the equation becomes linear, and that's a lot easier. So we have left 3W plus 90 is equal to 8W plus 5W plus 40. I would like to join my like terms over here because that looks annoying. So I'm going to write 3W plus 90. I'm not sure what's happening with my pen. Equals 8W plus 5W is 13W plus 40. All right, so I choose to get the W's over on this side and the numbers over on this side. That way we can keep everything positive. So I'm going to go ahead and take 3W away from that side and away from that side. And we get that 90 is equal to 10W plus 40. Oh boy, okay. And I'm going to go ahead and subtract 40 from both sides. And subtract 40 from that side as well. And we get that 10W is equal to 50, which means that, or with W, oops, let's see, what did I press? W, okay, my thing doesn't want to write anymore. W, there we go, is equal to 5. And if you know that W is equal to 5, looking back at the original, let's write that in by the way. Looking back at the original rectangle said the length was 3 more, So that means that the length is equal to 3 more than 5, so the length is equal to 8. And you could go ahead and should probably go ahead and test that out to see if it makes sense. I'm not going to do that because we're lacking time and we have to keep moving forward. All right. So now we have a different type of word problem, but similar idea. So we have a painting with width that's twice its length. So if I were to draw that out, it would look something like this. If that is x, then that would be twice x, which is written as 2x. Now, it says that the painting is surrounded by a border that is 2 inches wide. So let's get a border on here, and I'm going to make it big so it's clear. And that's not a great drawing, but you know what's supposed to happen here. So if this is 2x from here to here, and that is x, and the border is 2 inches, so from here to here is 2, and also from here to here is 2. That means that's 2x plus 2 plus 2. So the length here is 2x plus 4. All right, and that might be useful to know. Same idea here. If this is x going down from here to here, and the border, so from here to here is 2, and from here to here is 2, even though it doesn't look like it, then going from here all the way down to here is x plus 4, because it's really x plus 2 plus 2. All right, so now the painting is surrounded by a border that is 2 inches wide. If the area of the border, so the area out here is 232 inches squared, they want to know the dimensions of the painting. I feel like that is just really, really powerful that we can actually figure that out. So let's do it. All right, so the area of the border is actually the area of the big rectangle. So I'll just call it A of big minus the area of the small rectangle. So I'll call that A of small, predictably so. All right, so now the area of the big rectangle, let's use the space below. The area of the big rectangle is base, which is 2x plus 4. So I'll rewrite that because it might help us actually. All right. So the area of the big rectangle is 2x plus 4 times x plus 4, because it's base times height. So let's write that down. All right. Minus the area of the small rectangle. So the small rectangle is 2x times x. The area is base, which is 2x, times height, which is x. So 2x times x. So when you subtract that, you get the area of the border. And they kindly told us that the area of the border is 232 inches squared. So that's equal to 2, 3, 2. All right, now we can FOIL. And so we do first, which is 2x squared, outer, which is plus 4x, inner, which is again plus 4x, and last plus 16 minus 2x squared, because we have x times x, and that gives us 2, 3, 2. Now, oh, my 2 disappeared. Let's get that back here. Oh, there we go. All right, so fortunately, we have 2x squared here, minus 2x squared. They are like terms, which means they cancel each other out. And now it turns into a linear equation. So on your exam, I'm going to make sure that all of these equations are easy to work out like that. Even though you do know how to work out the harder ones, it will take you more time. All right, so 4x plus 4x, like terms. So that gives you 8x. I'm going to go ahead and do this quicker. So I'm going to subtract 16 from both sides. I subtract 16, and we get that 8x is equal to 216. And now I can divide both sides by, oh, that should not be 8x, should it? Let's see, did I miss something? I most certainly did. 2x times 4x is not 4x. Ooh, you must have been judging me. All right, 2x times 4x is actually 8x. 8x plus 4x is actually 12x. So now we have 12x equals 216. When you isolate the x, you divide both sides by 12. We get that x is equal to 18 inches. But always go back to what the question is asking for. The question is asking for the dimensions of the painting. So we know that x is 18. So now we need the dimension going across here. So that means 2x. So the length of the painting is 2 times 18. So the length is going to be 36. So dimensions are 18 inches by 36 inches. Oh boy, this pen is really, really doing some strange things. I think it's tired. I think this video is too long. All right, let's see what comes next, and if it's a long one, we will start a new video. All right, it's a good place to start a new video, so stay tuned for part 2 of part 2. All right.